Hello dear students. In this video we will see GATE 2004 question asked on relational algebra. We are given two tables or relations R1 and R2 with three columns in R1 A, B, C. Note that A is underlined. That means A is primary key in R1. Also D is underlined in R2. So this is primary key in R2 are the two relations. Now let C be a foreign key in R1 referring R2. So this attribute C here is referring D, that is primary key of R2. Although it is not given that C is referring to which column, but if not given, it should be understood that a foreign key in a particular table, like C is the foreign key, it will refer to the primary key of the other table. Suppose there is no violation of the above referential integrity constraint in the corresponding relation instances R1 and R2. What that means, you already know what is referential integrity, what is foreign key, and what are the rules. But just to make you understand again what they are talking about in this particular statement, I got a slide here. Just check that there are two relations R1 and R2 as given in the question, three columns A, B, C. A is the primary key. And let's see some other slide. Okay, this one is better. R1 and R2 are the two relations with A, B, C in R1. Note A is underlined, it is primary key. And R2 has D and E, D is underlined, it is primary key. And it is given that this C is the foreign key, which references D of R2, the primary key of R2. What does that mean? Is that any value under this C column, any value that you store under this C column must exist under the column D. So you cannot have a row like this 102, B3, and let's say 7. Senseless. How can you have C as 7 when C is referring the primary key D? It means that C can have an existence of a value only if that value exists in the other table's D column. This is known as constraint. This is the limitation on C we have put. We have said C, you cannot have a value which does not exist under D column. And this is called as referential integrity, obviously because C references D. So what they are saying is that no violation of the above referential integrity constraint in the corresponding relation instances R1 and R2 is done. So you should understand that all the rules are followed properly about foreign key. Now let's continue with the question. Which one of the following, they have given some relational queries, which one of the following relational algebra expressions would necessarily, check the word necessarily, produce an empty relation? The best way to solve this puzzle is rather to take any relations R1 and R2 as I have done here. Just check, I have taken ABC, I have taken some arbitrary values under ABC and DE under R2, and I have taken some values. Let's see, D is the primary key. So whatever values you show under D column cannot repeat and cannot be null. Also, A is the primary key. So whatever values you show under A column cannot repeat and cannot be null. I have taken some arbitrary values for B, B1, B2. Now let's talk about C. Whatever values you show under C, remember, must exist under D of R2. That's referential integrity. So I have taken 1, okay, and I have taken 4. Look, it's not compulsory that all the values of this D must be there under C. What's the rule? Come again, come again. The rule is that if you have some value under C, then that value must exist under column D. It's not said as the rule that all values must exist under C. Okay, so this is good, this table. Now Will this particular query, the first one, relational algebra, produce an empty result? Let's find out. This is what I have written. Project, this is the project operation, all of you know. Project C from R1 minus, you know the minus operation, it is set operation, project D from R2. So first of all, if you project C from R1, then you are going to get all values of C, that is 1 and 4. I'll better write it in one line, 1 and 4. Okay. Actually, it will be shown as two different tuples, rather like this, 1 and 4, but saving some space, minus project the values of D under R2. Now, D has 1, 2, 3, 4. These are the values of D. What do you remember about minus operation? A minus B. If A and B are two sets, A minus B will produce the result which contains the values that are present in A but not present in B. Just observe the values that are present in A over here. That is the first relation. 1 is also there in the other relation. 4 is also there in other. Can there be some value existing over here which does not exist in the other relation? Impossible, because C exists only if D exists. So any example you take, whatever values are there over here will be definitely found in the other result. So are we getting any values which are there in the left hand side but not there in the right hand side? No, we aren't getting any such thing. So definitely this will produce an empty relation. This will produce an empty relation, isn't it? Just check out. Okay, let's try again. Hope you understood the first option will produce an empty relation. Let's see the second option. Let's read the second option. Second option, this one, produces an empty result. This is the answer. By the way, watch out again. This was the second option. Let's see the first option. The first option is project D from R2 subtracted from project C of R1. Watch out again. Project D, this operation I am talking about, from R2 and minus project C from R1. Will this produce an empty result? Let's watch out again. I got an example to start with. This is the same example we have seen just now, few minutes back. You remember C is the foreign key, which references D. And we are running this project minus this project. First of all, what should be projection of D from R2? Now, the values of D are 1, 2, 3, 4, minus. What are the values of C in R1? 1 and 4. Now you find out the minus operation. The values which are there in the left, but not there in the right. You can see 3 and 4 are there in the left. Sorry, 2 and 3 are there in the left, but not there in the right. So the result will be 2, 3. So this will not produce an empty relation. Empty relation. Wait a minute. Before we jump to conclusion, I got another example here. We are still sticking to the first option. The first option here. Project D from R2 minus project C from R1. So, what do you say about these two examples? What I have done here is, I know that C is the foreign key, which references D. What I have purposely done is, I have taken all the values of D into C here, which is perfectly valid. If this is R1 and R2, then what is going to be the result of this projection? Project D from R2 is going to produce 1, 2, 3, 4, and project C is going to produce 1, 2, 3, 4. And if you now see, the subtraction is going to produce an empty result. This is an empty relation. So you may jump to a conclusion that even option 1 is correct. But wait a minute. They have said necessarily will produce an empty relation. Watch out that this is just one of the cases where all values of D are there in C. But this can be a case where C has only 1 and 4, whereas D has 4 values. In that case, we are not going to produce an empty relation. So by the way, option 1 is out of question. Anyway, we have already found they have asked which one of the following, the second option will produce a valid result. But let's check the third option. This says R1 should be joined with R2. This is like this: R1 should be joined with R2. And there is a printing mistake here. This is equal to operator. That means check whether C is equal to D. And finally, from your result, project the value of D. So let's see what happens for option 3 here. Let's go to a slide. Well, this is what we are talking about. I think so. Let me check or whether, yeah, project D. This is what they are asking. I have taken the same example over here. Now you just tell me when you join R1 with R2. I'm sure you know by now what is join, and we are checking whether C is equal to D. Only those rows will be selected. So obviously you know that this value of C matches over here and this value of C matches over here. So only this row and this complete row will be selected. And finally, we are projecting only D from this. So D projected will be 1 and 4. I hope you are understanding. This entire row will be in the result of the join, and this entire row will be there in the join result. And then we are finally projecting D. So D is 1 and 4. So this also is not going to produce an empty relation. Let's check the last option. We already have found the answer. By the way, 2 is the answer. But let's check the fourth option. This is join R1 with R2, and the join condition is C should be equal to D. And finally project C. So here we are with the same example. And yes, this is what we are doing. Joining R1 with R2, and we are selecting the rows where C matches D. And finally we are projecting C. Now, you know, when you are joining R1 with R2, this C here matches with this D over here. That's the condition. And 4 here of R1, C matches with D here. So this row will be selected in the join, and and this complete row will be selected. And finally, we are projecting C from the result. So only C, if shown, will show 1 and 4, which is again not empty relation. I hope you have understood this. By the way, by discussing these questions at such an extensive level is only just to keep revising these concepts of foreign key, referential integrity, and project operation and join operation. By the way, 2 is the valid answer for this question. Thank you very much.